Now, the next step of our lesson is we are going to look at how to place radian value angles, which are hard to recognize correctly in the coordinate plane. So as we saw in our last lesson, this is quadrant 1, this is quadrant 2, this is quadrant 3, and this is quadrant 4. And depending on how it rotates, our angle has a terminating ray that falls somewhere in the positive direction, which would be a rotation this direction, or a negative angle, which rotates this way. So just a quick review of what you saw in your last notes. Now, in the last notes, we talked about what each of these axis angles were in terms of degrees as your benchmarks on how to place an angle in the correct quadrant. So now we're going to look at it in terms of radians. So here is 0 radians. That's our starting point. If I go a quarter of the rotation, well, maybe we'll think of it this way. Our conversion is 180 degrees is pi radians. So if we think about that, this was 180, the negative x direction, and so that's now pi radians. So if you think about that, from this direction, 0 to 180 is 0 to pi, doesn't it make sense that the middle piece is pi divided by 2? In other words, pi over 2, or we could think of this as 1/2 pi. So 1/2 pi, or pi over 2, is 90 degrees. So now what we have is this chunk is 1/2 pi. This chunk is another 1/2 pi, which brings me to 1 pi. This would be another 1/2 pi, which brings this to 3 pi over 2. It's typically how you will see it as an improper fraction. Or if you like to see it as 3/2 pi, that would be fine. And then if we went another 1/2 pi unit, this would be 2 pi. So here's our big pieces. I'm going to erase some of the extra stuff that's in here, just so you can see all of those important pieces. We want that erased. We want that erased. Delete. Those are the major pieces that you need to know. And the more you work with radians, the more these are going to get kind of set in your mind. These are our benchmark values. Now we could also go in a negative direction. Let me show you what that would look like in a negative direction. If I went negative direction, then this would be negative pi over 2. This would be negative pi. This would be negative 3 pi over 2. And this would be negative 2 pi. So either option is useful. So now using this, we're also going to talk about reference angles. So depending on where your angle falls, every angle has a reference angle. And it just depends on where the terminal ray ends to determine how to find that reference angle. But a reference angle has two major pieces. It's positive and it's acute. And if you don't remember what acute means, it means between 0 and 90. Technically, it's not equal to. I shouldn't have those in there. At 90, it's a right angle. So it's a positive acute angle formed between your terminating ray and the closest x-axis. So let's talk about the different ways we would find these in terms of radians. The more you work in radians, the easier it is to work in radians. Okay, the more you convert to degrees, the less you're going to know about how to work with an actual radian angle. So we saw this in our notes on Friday or Thursday last week. If you're in the first quadrant, here's what a first quadrant angle looks like. This right here is theta. Theta is a Greek letter that we use a lot to represent an angle in trigonometry, so you're going to see that pretty frequently. If I have an angle in the first quadrant right there, then the reference angle is the angle itself, because terminating ray, closest x-axis, this is its own reference angle. So theta is your reference angle in quadrant 1. So if I'm talking about, let's say, a pi over 3 angle in radians, then its reference angle is pi over 3 because that's in the first quadrant. Okay, if I'm in the second quadrant, here's what a second quadrant angle looks like. It starts here. It ends over here. This is what we call theta, the angle that we're working with. Its reference angle is right here. Terminating ray, closest x-axis. This right here is the reference angle. Now, the way that I'm going to find that reference angle, if this were in degrees, I would do 180, which is a straight line's degree measure, and I would subtract off my angle. But because it's not in degrees, it's in radians, I'm going to do pi minus theta. So do pi minus theta. That's the equivalent of 180 degrees minus theta. Okay, third quadrant. Third quadrant, here's the angle. Starts in the same position. It always starts in the same position. So here's theta. It's all about that rotation. There are an infinite number of angles that could start with this purple line that I just drew and end with that purple line. It just has to do with how many times I rotate around this axis. The reference angle here, though, is terminating ray, always the closest x-axis. It's always x. So this right here is the reference angle. So to find that, what I'm going to do is take the whole piece, which is theta. This is the bigger angle, is the big theta. And I'm going to subtract off pi, which is the flat portion, from 0 to 180. And last but not least, fourth quadrant looks something like this. Starts here. It ends here. I don't know if you can hear the children screaming in the background of my video. That's just part of the Hellickson charm right now. That is theta in the fourth quadrant. And the reference angle is formed by the terminating ray, closest x-axis, which is here. So it's the remainder of the full rotation. So we're going to take a full rotation, which is 2 pi. Again, I'm basing all of this off of those degree conversions. 1 pi is 180, so 2 pi is 360 degrees, minus theta. Now, I'm just going to make a note of this, and I don't remember if I noted this on our last notes, but these formulas work when your angle theta is positive. So positive between 0 and, in this case, 2 pi. So it needs to be between 0 and 2 pi radians. If your angle isn't in between 0 and 2 pi, then my recommendation is add 2 pi, which would be 1 full rotation or 360 degrees, to find a coterminal angle that is.